Exercise A03 is going to once again follow up on the previous one. We have handled so far one of the possibilities offered by our little menu. Possibility 1 is compute and display the sum of variable a and b. So exercise A03 is about finishing off the exercise by actually implementing all the other choices offered by our little menu. So this is going to be an opportunity for us to use serially arranged conditional statements. One thing important, we need to use serially arranged statement, which means we need to make sure that we are going to test if choice equal 1, then I do something. End of my if statement. The next if statement, which is going to be executed, no matter what is the outcome of the first test, is going to say if choice equal 2, then we do something else. So each test is going to be independent from one another. Let me go back to Raptor. This is where we left our program. Okay, nothing new here. This is our first conditional statement. I'm going now to solve exercise A03. Keep adding conditional statement one after the other. And this is what we mean by serially adjacent. No matter what is the outcome of the first test, choice equal 1, I'm going to maybe execute some code, maybe do nothing. But then I move on to this second conditional statement. This is a little dialog box that prompts me for a condition. My condition will be testing if choice equal 2. Done. This is my conditional. I'm going to keep going and introduce all my conditional, and then I will go back and populate them with appropriate things to do statement. Third conditional, choice equal 3. Oops, little typo there. Choice equal 3, enter. Another conditional, and I will be done. What to do when choice is equal to 4. Double click on the diamond. Choice equal 4. There we go. So now I have the structure of my program. Okay, 1, 2, 3, 4 tests that are going to be done one after the other. In each test, if the condition is true, then I will do some work. The work consists in outputting something. In this case, choice equal 2 means that the user wants to actually compute the difference of a and b. So a minus b equal, as a string. I concatenate to the string the result of computing actually a minus b. And this is an expression. Done. Output statement again here for this third conditional. What I'm going to display is the string a divided by b equal, concatenated to the result of actually dividing a by b. Done. Let me scroll down a little. Output statement again right here. Double click. This is my dialog box. A times b equal, concatenated to the result of multiplying a by b. Done. So this is, now my program is responding to any possible choice. Okay, first step is get two values for a and b. Second step, so the first step is pretty much, let me take an inking pen here. The first step is pretty much here. Get two values for a and b. Second step is display the menu on the screen, followed by actually read a choice from the user, which is going to tell us what the user wants the program to do. And then there are 4 different choices, so 1, 2, 3, and 4 conditional statement. Every time we check one after the other all those conditions, if choice is equal to 1, 2, 3, or 4, it's going to trigger the appropriate put statement, output statement on the screen. One thing to notice, if the user gives us the value 3 for this variable choice here, what's going to happen? Well, choice equal 1 is going to be obviously false. Choice equal 2 will be false. Choice equal 3 will be true, thus triggering this display on the screen. Choice equal 4 will be false, and we reach the end of our program. So what I'm trying to get at here is that even though the structure of our program means that each conditional is evaluated one after the other, because of the way we wrote the code, only one of them is going to be ever true, because a variable choice can have only one possible value. Okay, so we wrote this code. Let's execute it. Start, give me a value for A. Well, let's try 300. Okay, give me a value for B. Let's try 10. Display the menu on the screen. Let me scroll down. Display the menu on the screen. Read a value for choice. Well, I'm going to choose something different than what I did so far. Let's say even 4, the division. Our numbers are right for this. Okay, you see choice 1, 2, 3 are avoided. Choice 4, and this goes a little fast, so I'm going to slow it down next time. Choice 4 was actually, this condition was true, which led to put this on the screen. So A times B equals 3000. Is it enough for me to declare that my program works? Once again, no. So I'm going to execute this again, but I'm going to slow down the execution by using this little cursor here. Let's run. Give me a value for A, 300. I'm going to keep the same value. Value for B, 10, sorry. And there we go. We're going to display things on the screen. I'm scrolling down. We're going to ask a choice. I'm going to pick 3 this time. Choice 1, skipped. Choice 2, skipped. 3, executed. Choice 4, skipped. This is a result of our execution, which is correct once again. And I can keep going like that until I've been testing all the execution path on my program. Oops, let me reset this. I started the program by error. I can re-execute like this just to test if choice 1 still works, choice 2 still works, etc. Now I'm going to do something a little bit different. I'm going to give a value for A, which is, let's keep the same, 300, a value for B, which is 10. I'm going to display some stuff on the screen, and I'm going to now take a choice, which is 5. Some of you would have noticed probably that when I typed 10 I made a typo. It's not going to matter, you're going to see why. I choose here an option that is not a valid option. Let's see what happened. Choice 1, not selected. Choice 2, 3, and 4, not selected. Nothing was selected, no condition was true, nothing was executed. I just went through the program, going in the else part of each if statement each time, and ended up with the end program. So what does this show? This shows that this is how you test a program. You test every possible value, and then you try to test values that do not make sense, just to see how your program is reacting. Never assume that people are not going to make errors using your program. The difference between a robust program and a non-robust program is the capability to handle bad input. And we are going to come back onto that.